So welcome to part 5 of the lecture series on Introduction to Computer Networks. And we will jump to the point from where we left off. And here we go. So when we are considering a network which basically has computers and routers and all of these devices connected and talking to each other, they need to follow some rules. So the best analogy that you can have is by following how humans react. So humans, they communicate with each other using what we know as the human protocol. So let's say we have Alice and Bob. Alice says hi, Bob says hi. Alice asks the time, Bob tells the time. So this exchange of information between Alice and Bob is defined by the social norms and what we can refer to as the human protocol. In computer networks, protocols are basically rules which define the format of computer interactions. So they define the format of the messages which are being sent and received. They define the order of the messages which are being sent and received, and the actions which are being taken upon the transmission and the receipt of the messages. So an example of a computer protocol would be, a computer opens a connection to the web server confirms that the connection is open, the web client then asks for some data, the web server sends the data. So this concept of protocol is a very simplified example here, but this is what the whole network is based on. They are specific rules which define the format of the messages which are being exchanged, the order of the messages which are being exchanged, and also the actions which are taken. So when we are talking about the internet, we refer to something that we call as the hourglass architecture. So the hourglass architecture is based on the OSI and the TCP IP model. And if you see here, this is implying the OSI layer structure. So the physical layer has a set of protocols which run in the physical layer. Next, we have a set of protocols which run in the data link layer. Next, we have the internet protocol, which runs in the network layer. In the transport layer, we have TCP and UDP to be the most common protocols. And as we go up, we have HTTP, FTP, SMTP as the application protocols, etc. So the reason why we call this an hourglass architecture is because all nodes on the internet run the IP protocol. However, all nodes may have one or more links connected to it. So each of the links which are connected to a given device will have data link layer protocols and physical layer protocols. And if you go above the IP protocol, we have on each device multiple applications which are running at the same time. So each of these applications are able to use a bunch of these applications. So IP is the common protocol which is running on all devices, and for each device all links would run the data link and the physical layer protocols, and each device has multiple applications running, and they will run a bunch of these protocols. So once we have the basic understanding of network transmission protocols, we now try to look at the structure of networks. So first of all, we have already mentioned that the internet is a huge collection of interconnected devices. So in that aspect, we define the network edge to be the boundaries within a network. So let's say you have a network here. Let's call this N1. You have a network here. Let's call this N2. And they both connect through a router to the internet. So therefore, in this case, the network edge would mean that this network and all the devices which fall within this network would have some form of limitation in terms of the administration duties and also the ownership. The same applies for the edge of this network. The access network, on the other hand, is basically the part of the network which allows these individual networks to connect to the larger network. So if we try to redraw the previous diagram, and these two connect to the router, which connects you to the internet. So the access network is the part which allows you to connect to the internet. Next, the network core is basically the network of interconnected routers, and we also refer to it as the network of networks. So this is basically the border routers and all these high capacity devices which are connecting massive networks and allowing these networks to be connected to each other. So this is the core or the heart of the internet. So there are many different types of networks, and we can classify them based on three different aspects. In terms of the transmission type, they can be classified into broadcast links or point-to-point links. In terms of scale, which is basically the size of the network, we can classify networks into personal area networks or PANs, local area networks or LANs, metropolitan area networks, MANs, or wide area networks, WANs. And finally, if we used the media-based classification, that is the way that these networks are connected, they are classified as wired or wireless. So the broadcast link basically works where we have one single channel to be shared by all the other hosts. So this is the channel that is shared by each of these hosts, and what happens is that whenever any of these hosts wants to send in a packet or some data, it is broadcasted to all the devices which are connected to this single channel. There is something that we refer to as the address field in the data packet, and this is a field which specifies the intended recipient. So when all these receivers receive the broadcasted packet, each of them would match the address field. And if it matches, it understands that itself is the intended recipient. If it doesn't match, it drops the packet. On the other hand, point-to-point links are basically direct connections between two network nodes. It could be one-to-one or one-to-many. As you can see here, point-to-point or point-to-multipoint. In both of these examples, in both these cases, they are direct connections. So the whole network consists of many connected pairs of network nodes. As you can see here, this is one connection, but these are multiple connections, all of which are individual point-to-point links. So a packet which travels from source to destination may go through multiple intermediate connections. So if a packet is being sent from the internet to one of these hosts right here, it will need to go through the internet, and the internet backbone connection comes to the tower through the wireless cellular connection into the antenna, and then comes into the target destination. So one thing to know is that smaller networks may use broadcast links. However, larger networks, in almost all cases, uses point-to-point links. So in terms of the scale-based classification, the smallest would be PANs, that is personal area networks. They are organized around an individual for personal use, and the best examples for this would be, smart watches, smartphones, laptops, health wristbands, etc. And they are connected via, short range technologies, for example, Bluetooth. However, it may also use Wi-Fi as well, but they are generally limited within a very small geographical range. One of the reasons that we create PANs is to minimize the transmission delay by keeping all the devices in a close range. The next in size would be LANs, something you probably might have come across in terms of the terminology, and they are limited to a single building, a campus, and in terms of the size, they may span up to a few miles. It's widely used in offices, universities, etc., and it commonly is established using Ethernet or Wi-Fi connections. The primary use of LANs is basically to be able to share resources. For example, there could be a mail server, a file server, a printer, etc. And all of these are connected through the LAN network so that the hosts on the LAN are able to use these shareable resources. So two terms which might come up are SOHO LANs, which is small office or home office LANs, to SME LANs, which is small to medium sized enterprise. The third, in terms of the size, would be metropolitan area networks, or MANs. They are slightly larger than LANs because they are intended to cover metropolitan areas or very large institutions like a very, very big campus. And one of the very common uses of MANs would be to provide public services or private services such as cable TV or utility connections. And the main focus of MANs is to allow effective data transmission. For example, you have your electricity meters, and the data which is being collected from your home needs to be transferred onto the utility office so that proper billing could be made. So it requires all this data to be transmitted across the MAN network to some other part of the city. It's commonly operated together by large organizations and public utilities, and they're not really a part of a small client business model, but rather a citywide model of network. And the largest in terms of the network would be wide area networks or WANs, and it actually spans across a very large geographical area, which may be countries or continents, states, and um, one of the things which is different for WANs is that they are connected to sub networks or something that we call subnets, which are basically smaller networks within networks. So if we look at this diagram here, uh, within a very small space, there could be a personal area network or a PAN. A local area network may exist within a building or a couple of buildings. When you are connecting all of these together across the city or the metropolitan area, it would give you the metropolitan area network. And when you are connecting multiple of the cities and states and countries, you basically get the global wide area network. So it is owned and operated by very large organizations and network providers. We call them tier one operators, and it uses very high capacity links. The reason is because, as you can see, the higher you go in size, the more data it needs to be able to transmit. So therefore they are more expensive, and a lot of these policies are defined by the government and global organizations, which kind of specify which man is allowed to access which one and which regions are allowed to transfer data to which other regions, etc.